Okay, so today I'm going to talk about touch, because obviously touch is really becoming a really central input modality for all of our devices, not just the smartphones in our pockets, but also the screens in our car and smart appliances in the home and so on. So we really want to think, if it's going to become such a kind of forward-thinking and kind of futuristic modality, we really want to think critically about it, and that's what I want to kind of show you guys today. So I put up on my first slide here the iPhone 6. How many people have this device, an iPhone 6 or 6 Plus? So, I don't know, a good number of people, 20 or 30 or something like this. So this actually is a really capable computer. It has about 170 gigaflops of processing power, which is sort of a crazy number, but what does that actually mean? But what it really is sort of remarkable about this is that if you took it back in time with you 20 years, so let's say you took an iPhone 6 back in time to 1994, it would actually be the third fastest computer on the planet. Okay, and now you're just carrying this device around in your pocket. So for reference, here is the third fastest computer in 1994. And the iPhone 6 actually has it handily beat. This is only 135 gigaflops peak processing power. And obviously, this is the size of a room. And so actually, if you cumulatively, and this, by the way, was what Los Alamos National Labs was using as their primary kind of heavy lifting computer. And now, again, you have that processing power in your pockets. So what's really remarkable is that we're now carrying these devices in our pockets that have this kind of computation power. And for the most part, we're sort of tweeting and sending photos to each other. It's pretty remarkable. And it's very likely they would have really drooled over this back in '94. So it's very likely that if you added all cumulatively, all the laptops and tablets and smartphones, at just this conference alone, we would have had more compute power than many nations did 20 years ago. So pretty remarkable. So if we actually kind of dig into this a little bit more and kind of look at an exploded view of the iPhone, what's really remarkable is that the computer, which is right here, is actually among the smallest parts of a modern device, which is pretty remarkable. You think of an iPhone as a really modern computer, but the computing part is actually pretty much the smallest component. The biggest component is the touchscreen and the battery, so the human and the power part. And actually the processor, where that 170 gigaflops number comes from, is just that little square there in yellow. And if we sort of explode that a little bit and look at the actual CPU die, most of that processing power comes from the GPU. And so that little patch of silicon, the size smaller than a penny certainly at this point, is more processing power than this gigantic machine. So that's really remarkable. So what you guys all know is that computing power has really exploded. It's following sort of Moore's law, so processing power and memory have all really increased sort of exponentially. And then even things like bandwidth and screen resolution continue to advance, maybe not exponential, but certainly always kind of going forward. So this is awesome. But if we look at human factors, it's not such a good story. So, our fingers haven't become pointier. Our vision hasn't improved to read, postage stamp-sized screens. Our dexterity hasn't improved. And, if you've been playing a lot of, Candy Crush or Flappy Bird or whatever, your intelligence might have even, gone down a little bit. So because of this very simple fact, not less so about computing factors, but much so about human factors, is that we now have these incredibly small computers, like a smartwatch, and the industry really doesn't know what to do with them. And the problem is really the human interface. This is, again, if you took this back to 1994, it'd probably rank on the top 100 computers in the country. And so what I don't want is for this to be our future, right? Where in order to do sophisticated things on our devices, we need to make them big. So right now, the industry is sort of thinking that size and capability are sort of linked. So if you want to make a more powerful iPhone, or you want to do more powerful things on your iPhone, you get an iPad. Right? You just have a bigger screen. It's not that the computing power changes, it's really just the screen size that's changing. And I really don't like this because it's a very poor design strategy. One is that it means that small computers, which we can now make very handily, are going to be sort of dumb. Basically, the smaller the interface gets, the dumber the interface has to get. And that's really problematic, I think, from sort of a human-computer interaction standpoint. So breaking size and capability apart is this really big grand challenge that I think the industry needs to tackle about if we are going to sprinkle these computers around. So if we look at this sort of from a historical perspective, an interface perspective, there's really been these 4 eras of computing. We went from sort of displayless mainframes to text-based terminals, and then on to kind of the graphical user interface and mouse-driven era, and then most recently into sort of this touch era. And what's been really great about this is that the difficulty of operations has reduced over time. The difficulty of the system has reduced. So the fact that I can give an iPad to a 4-year-old and they can use it is a real testament to how much progress we've made in interface design. If I gave even one of you in the audience, let alone a 4-year-old, like a VT125 text terminal, and I said, why don't you open up a file and print it, you would just be there trial and error, like open, print, P, close. It'd just be completely hard to use. Even me with a computer science PhD would find it really difficult to use. So we've made tremendous strides in reducing the difficulty of these systems. Simultaneously, we've also really improved the capability. And it's not just because computers have been getting faster and better, but because the interfaces have become more sophisticated. So the fact is, I can edit a paper or edit a movie much better on a GUI system than I could on a text terminal or punch cards, right? Editing a movie on punch cards, like, what does that even really mean? So this is great. Every single one of these evolutionary kind of advantages has made things easier. We can do more sort of in less time. But what really disturbs me about touch is that we actually do less sophisticated things in our touchscreen devices than we did on our desktop computers. And this has actually broken the trend for really the first time in computing history. So just to go back to my earlier examples, if you wanted to edit a movie or write a paper, it is definitely easier on my desktop than it is on an iPad, for example. So what we really want is this. We want this trend to continue. So if we go back to a device like the iPhone 6, people would really say, this is sort of the pinnacle of the smart, touchscreen interface. It's so natural and it's so intuitive, and they always use these descriptors. But I would say, actually, these devices don't deserve either of those two descriptions. If you look at a much older multi-touch device, like a guitar, I think this is actually a much more sophisticated multi-touch device. It captures a lot of rich dimensions of our touch, things like shear and contact area and pressure, things that devices like the iPhone don't capture. So that's why you see a lot of bands playing on guitars and not too many bands playing on their iPhones. What an iPhone or any real device, I don't mean to just pick on Apple here, but really most of these devices only capture one dimension of touch, and that's the touch location. So you get into kind of an XY coordinate. But if you think about all the incredible ways we use our hands, it's very naive. So if we look at this here, you'll notice it's sort of one finger, two finger, three finger, four fingers, like pinches and poking at screens, maybe have swipes. But this is a very kind of basic vocabulary, and we've had it for about 7 or 8 years now, and it hasn't really seen a whole lot of refinement. But if we look at how humans actually use their hands, really natural, we don't go around really the world poking our fingers at things. At this conference, I don't 5-finger handshake you or 2-finger get dressed in the morning. The number of fingers isn't the important thing. It's not the human-centered dimension. The fact is we use things like grasp and pose and parts of our fingers and pressure and shear and all these rich dimensions of touch that we sort of take for granted and don't even think about. That's truly natural, not just poking different numbers of fingers at flat screens. So what I think the real challenge is to unlock the potential of small computing is not necessarily just making the screens bigger. That's sort of the obvious, naive way to do it. But what you really want to do is increase the richness of touchscreens so you can do more in the same small space. So you make them better, not bigger. And I want to show you sort of 3 example projects of many out of my research lab at Carnegie Mellon that sort of try to tackle this problem. And obviously they won't look exactly like this, but I want to kind of illustrate what this future might look like. So one is type of touch, right? We actually touch the world with different kind of types, different parts of our finger, for example. We scratch an itch or knock a door and so on. And if you look at a mouse as a comparison point, this, within a single hand, gives you left and right mouse buttons, which is great. It also gives you a scroll wheel that you can go up and down and also potentially click, and you can translate a cursor in 2D. So that's a lot of kind of dimensions of input within a single hand. And it's why you can do actions like this, where you select a bunch of cells in a spreadsheet, for example, and you can easily copy and paste these quite trivially. So what we did is we came up with this technology that tries to understand how you're touching the screen. So not just location, but the type of touch. So for example, your fingertip, your knuckle, or your nail, or also a stylus potentially as well. And it does this acoustically. So it actually waits for the touchscreen to report the touch event. And then by looking at the vibroacoustics using the accelerometer, we can actually detect what basically that touch sounded like and actually try to figure out how the user touched the screen. So if you have this sort of basic technology, what can you do with it? So let's return to sort of the copy and paste example. So here I can scroll as usual, but now I can use my knuckle to select. So I can highlight this entire paragraph in the middle and say paste, and we're done. So because I have 2 modes on my finger, all of a sudden I don't have to do this kind of crazy, tap, double tap and hold, or tap and, I sort of just tap at my phone until the little things show up and then drag, which I'm sure is not the way that the Android team envisioned it. Here's another example with images. So what I can do is, again, I can pinch and zoom as I normally would. We can recycle that. But now I can do lassoing again with my finger. And we can also introduce another primitive, which is really nice, where I can lasso a region. But now I can actually knuckle tap, basically to bring up a context menu. And you could do this on an email or a PDF, whatever you want. And you can basically pack functionality into the screen without having to use a toolbar. So that's one example. Another way that we use our hands, and sort of a dimension that we don't exploit now on touchscreens, is finger pose. And what I mean by that is sort of the angle of attack, the pitch and yaw of a finger. So here's some prototype software that's tracking the angle of the finger. And you can see it does a pretty good job of estimating it, but it's not perfect. It's still definitely a prototype. So you can say, OK, what can we do if we could have a touchscreen that not only gets position and type, but also sort of the pitch and yaw of a fingertip? So here's one example. This is a fun demo that we made, is have a little spaceship fly on the tip of your finger. So even though you're only pointing and you're only getting a 2D location, what you're actually getting is sort of a ray into a 3D scene. So this could just as easily be a gun with a laser pointer coming out of it, and we're pointing in a 3D room. This is a really crude demo. Again, this is sort of research, but imagine this was a real smartwatch. You guys are getting the early scoop here. Is imagine being able to change the volume, not by using some ridiculously tiny volume bar, but I can now adjust this with a twist of my finger. So in this case, we're using the yaw of the finger. And likewise, with a mapping application, which is really pretty crude right now, we can now do panning and zooming quite trivially. This is really quite hard to do. Apple introduced a mechanical scroll wheel to be able to really do sort of scrolling and fluid zooming. But the fact is our fingers have this power. We don't have to bolt on extra things. Our fingers are really quite capable. So another really powerful dimension is hand grasp. So far we've been talking really about finger dimensions, but your fingers are connected to your hand, and it's really them operating in concert that makes it very powerful. So if you look at how we use tools, we always employ very particular grasps, precision grasp and so on, to really manipulate them. And it's actually that grasp that brings power to the tools. And what's also unique about these grasps is that they have quite unique poses. So how you hold a hammer is quite different than how you hold a scissors. And we can take advantage of this interactively speaking. And what's very important to note about tools is that humans have always surrounded themselves by tools. So when I want to cook dinner or build a treehouse, I augment that activity with tools. It's human nature. But in the digital world, we really only have one tool, our fingertip. And what people have said for 20, 30 years is say, oh, well, we'll throw in a toolbar with all those tools in it, and now, bam, you've got tools in the digital world too. But I would actually say that this is not a great paradigm. It's helped us get this far in computing, but we can do a lot better. The fact is, if you think about how you actually manipulate tools in the real world, is there any tool that you can manipulate just by poking your finger at it? At the very best, when you select, like the eraser or pen or measuring tool, is all you're doing on that digital screen is you're just positioning the tool in space, but you're not manipulating it. And what's powerful about grasps and tools is the grasp allows you to manipulate it in complex ways. So this, I think, is sort of a bit of a basic kind of conception of how we might see tools. So here's a very crude demo. Obviously, it wouldn't ship like this in a product, but it's meant to be illustrative, where we can analyze the hand pose on a screen and summon different tools. So we can actually have tools. There's no toolbar in this interface. We're actually using the natural modality of our hands to summon different tools. And they're tools you already know how to use. So let me just show them all together here. So what you do is we actually train the system by having users grab a bunch of different tools, these ones laid out here. And then we said, well, imagine that was on the screen, but we're going to take the eraser away from you now. Put your hand down on the screen. And we trained our system with 20 or 30 users, different grasps. And then we had our system basically through machine learning try to figure out what tool they were trying to do. And once you had that tool, then obviously the tool had its own logic. For example, the mouse would let you select or zoom in and so on. So this is sort of a primitive incarnation of what tools might look like existing in sort of a minority report interface in the future, not just a toolbar that you poke at with your fingertips. And very luckily, there's a lot of dimensions of touch that we have yet to really explore. There's a lot of other researchers working in this area. It's not just even pose and type and grasp, but there's shear and torque and pitch and contact area and all these wonderful things that future touchscreens really can take advantage of. So just to give you sort of, again, a historical overview, what we've seen in sort of mobile input and sort of in touch input is we've transitioned from buttons to stylus and single touch, sort of Palm Pilot and Klee era, to multi-touch. And each one of those evolutions was a really significant boon in what we can do with those devices, and certainly, how they've impacted society. And now, today it's been like 7 or 8 years since the iPhone came out, and we've really not seen a tremendous evolution in the kind of multi-touch experience. If I had an iPhone 1 with me right now and I showed you these two devices side by side, yeah, the iPhone 6 is a lot thinner and it's faster and the camera's smaller. All those things we could have predicted 7 years ago, but I'm not sure we would have predicted that the user experience was basically unchanged, which is pretty remarkable. So what I think we're going to see next, sort of the next wave, is moving to what I'm tentatively calling sort of rich touch, where multi-touch was really about counting the number of fingers on the screen, hence the multi kind of prefix. But really what we want to do is capture all the rich dimensions of touch and have devices and experience that really take advantage of our hands. And I think if we do this well, and again, this is sort of early stage at this point. There's only a handful of people really around the world really digging into this problem. But we can continue this trend and sort of keep on capitalizing on these advances in computing. And what I really hope, and what kind of the takeaway message is that if we really want to make full use of these kind of platforms, which are extraordinarily constrained by virtue of being small, which is necessary in many contexts, including, for example, the home. You don't want to have 70-inch plasma screens plastered all over your home. That makes it quite invasive, let alone the expense. This is really the kind of gateway onto the body and into the home, minimally obtrusive. But when they go minimally obtrusive, it means they're small. And so we need to get a lot more clever than just shrinking down sort of current smartphone interfaces down to the wrist. Touch was never really meant to scale that small. So with that, thank you, and you guys should grab me at next break if you have any other questions.
Thanks very much, Chris.